Hello everyone. So today we are going to discuss another problem. This problem is on subgame perfect Nash equilibrium. So let's begin. So we are given consider the following perfect information game, and matter of fact this is an important topic in game theory. Okay, so for just your knowledge, this is an important topic in theory, right? So we are given consider the following perfect information game where player 1 can choose between L and R, right? So suppose player 1 chooses L, so then player 2 can choose between small a and small b. So if player 2 chooses small a, then payoff for player 1 is 2 and payoff for player 2 is 1. Similarly, if player 2 chooses b, so payoff for player 1 is 4 and payoff for player 2 is 0. So now similarly we can analyze the rest of the game tree. This is known as game tree, right? Game tree. So we are given to find the backward induction solution. So backward induction solution means for any particular terminal node, we have to backtrack and reach to the root node and see which particular strategy profile leads to the most optimal or the most beneficial outcome for both the players. So if we see the first backward induction solution, we can see that if player 1 chooses L and then player 2 chooses A, so we land 2 for payoff of player 1 and 1 as the payoff for player 2, right, in the left part. And consequently in the right part, if we see that once the player 1 chooses R, player 2 chooses E to maximize its payoff, and player 1 will choose out of W and E, it will choose 1, because you can see that 1 and 0, 1 is greater, so 1 it will choose. And from here we will say that player 2 will choose out of these two, so we can say player 2 chooses E and player 1 will choose W. So then we will have this strategy profile L, W, which are of player 1, and A, E, which is for player 2. So this is the strategy profile. Now since we can see that we do not have right, that is the R in this particular game, so we will only continue with L and A because first move has to be chosen by L. So L and then A, so there we will land LA as the outcome and the particular payoff will be 2, 1. Now another backward induction solution would be for the R part. So if we see in this, the strategy profile is player 1 chooses right or R, and then player 2 will choose D because it has the highest payoff for player 2. And in the lower part, player 1 will choose W and E, out of which it will choose W because it has higher payoff than 0. So if we go backwards, so 1 will choose W, 2 will choose D because it has greater payoff, and 1 will choose R because this is the particular case which we are dealing with. So strategy profile will be R, W and A, D, because for the second state in here we also need to check, since this is also a game or subgame in itself, right? So in this subgame player 2 has to choose, and player 2 sees that 1 is greater than 2, 1 is greater than 0, so it will choose A. Similarly we will have R, W as the strategies for player 1 and A, D as the strategy for player 2. So the outcome or the connected outcome would be R and D because no other particular strategies are connected or in sequence. So we have R, D, so which will give the payoff as 3, 2. So now the first question is completed. The second question is write down all the strategies of player 1. So for player 1, we can see that in this game the player 1 will choose R or L, then W or E. So the strategies will be the Cartesian product of all these four. So we will have L comma W and L comma E, R comma W and R comma E. How will we say that? We will have L comma R Cartesian product W comma E, which will give out this strategies. Similarly, we have for player 2 A, B, C, D and E. So then we will have, since we have A and B, C and D and E as the separate branch, so we will have the Cartesian product here. So then we will get all these 6 strategies. Now coming to the fourth part, write the strategic form associated with this game. Strategic form is also called normal form, in which we create the table and associate all the payoffs with it. So strategic form of the game is, we will write down all the strategies of player 2 on the top and all the strategies of player 1 on the in the row format, and then for LWAC we will find the payoff. So for L, W, A and C, we see that L and A are connected, right? So after L we can use A, but we cannot choose C or W after choosing L. So we will have L and A and the payoff will be 2, 1. So we get 2, 1. Similarly for LWAD, L, W, A and D, we see that the connected part here is 2, 1 again, because only L and A are connected here. So we will say that it is 2, 1 again. Similarly, we will fill out all the entries in this table, and that will be the strategic form for this game. Now finally, we see, is there a dominant strategy equilibrium? So if we see the table, and try to eliminate out any of the dominated strategies, we see that we are unable to do so. Suppose we take here, means we can start it with B and C. Suppose we start with B and C, that it is less than BD, we can do that, but ultimately at the end we will see that it is not possible to screen out all the strategies into a single cell. So we will say that there is no dominant strategy equilibrium. Thank you.